Assalamu alaikum dear students. Hopes you all will be fine. Today we will discuss the following topics which are about relay and PLC based control panel and PLC advantages. This is lecture 6 and week 3. You can find this PDF and video at portal.suit.edu.pk. So we will switch to the next slide. Before going to discuss today's topic, I will review the previous lecture. In the previous lecture, we have studied about the brief history of PLC, in which we have studied about the mechanical devices which had been used in the control application, the availability of PLC. We have discussed that the PLC which are available in three different types. The first one is single board style PLC. The second availability of PLC is shoebox style PLC. The third one is modularized PLC. So these are the three types in which PLC are available. Parts of modularized PLC. Here you can see the parts of modularized PLC. Power supply, CPU module, input-output module, and programming device. CPU means Central Processing Unit module. I/O module means Input-Output module. So these are the modules. The module of power supply module, CPU module, I/O module, and programming device. These are the major parts of modularized PLC, and modularized PLC can be plugged into a rack. So these are the few topics which we have discussed in the earlier lecture. So we will switch to the next slide. These are the few objectives which we will study today. The first objective is a relay-based control panel, in which we will study about the control panel which is designed by relay. You know relay, which is electromagnetic device in which coil is attached. In that coil, if we pass current, it will generate a magnetic field. And we know that the relay has two terminals. The first terminal is normally open and the second one is normally closed. So we can develop a logic using relay. The second objective is PLC based control panel. The PLC based control panel has been this PLC based control panel is a new panel, and this panel replaced the relay based control panel. PLC advantages over relay logic. So PLC have several advantages over the relay based control panel. Here you can see the 6 advantages of PLC over relay logic. The first one is increased reliability. The second one is more flexibility. PLC has more flexibility than relay logic. By using PLC, we can increase the reliability of the system. The third one is the lower cost. PLC provide lower cost solution. And the fourth one is communication capabilities. PLC can communicate with other module by communication port or communication module. Fast response time. PLC has fast response time. due to solid state devices connected in the PCB of PLC, and it is very easier to troubleshoot the PLC system because in case of relay it is very difficult to control the devices by means of PLC. By means of PLC, by means of PLC, we can by means of PLC we can troubleshoot the hardware very easily. So we will switch to the next slide. Here you can see the pictorial diagram of relay-based control panel. So here you can see the relay. These are the relay, and these are also relay. These relays has been connected with each other in order to make proper logic control, and this logic control can be used for specific control application. So there are few points about a relay based control panel. The first point is relays have to be hardwired to perform specific function. If we design a system, it will require wiring, and for that wiring if we use relay, so this control circuit will be called relay based control panel. Second one is when the system requirements change, the relay wiring has to be changed or modified. If plant manager says to change the control application for specific control circuit, so we will rewire the whole circuit or control circuit in order to fulfill that requirement. So it is very necessary to change the rewiring of the control circuit. In, in extreme cases such as in the auto industry, complete control panel had to be replaced since it was not economically feasible to rewire the old panels with each model changeover. You have seen so many auto industry in which it may be possible to control or to remove complete control panels from another module. So it is very difficult and it was not economical feasible to rewire the old panels. So these were the hurdles faced by the technician in relay-based control panel. So we will switch to the next slide. Here you can see the pictorial diagram of PLC based control panel. This is PLC, and here you can see the relay. These are the relay, and these are the three-phase contactor or single-phase contactor, which has to be used for the application of motor control. Here you can see the wiring from PLC. This may be the input and this may be the output, and the input of PLC has been wired to the switches connected in this system, and the wire has been gone in this direction in order to take the input from switches or electrical mechanical devices. And here you can see the output of PLC. The wire of PLC output section has been connected to the electrical component used for to control motor operation. This PLC may be from Siemens or Omron or Keynes. Here we can connect different PLCs, but ladder logic programming is same for all PLCs. Programmable logic controller. Programmable logic controller has eliminated much of the hard wiring associated with conventional relay control circuit. In previous slide, if we go to the previous slide, you can see the conventional control relay circuits. Here you can see different relay. This one is relay and these are all relay. By using these relay, we can control any motor or light or any specific operation in industry. These wires can be connected in series or parallel in order to make AND OR logics. So it was very difficult to wire the whole panel again for the modification of a new plane for control circuit. So that's why so that's why in order to eliminate rewiring, we should use programmable controller which can eliminate these hard wiring associated with conventional relay control circuits. It is small and inexpensive compared to equivalent relay-based process control system. So this system here you can see in the panel, it is very small. It is very small than the previous and it is very inexpensive compared to the relay-based process control system. Modern control systems still include relays, but these are rarely used for logic. We can use relay in modern control system only for the specific logic, but in most cases we can use PLC for specific application because in PLC we can use ladder logic programming for the specific application. So we will switch to the next slide. PLC advantages of our relay logic. So there are several advantages of PLC over relay logic. The first one is shown in the slide and this is increased reliability. Here you can see the pictorial diagram of PLC. We know that PLC has 4 or 5 basic building blocks. The first building block is power supply, the second one is the input, the third one is the output, and the fourth one is CPU. CPU means central processing unit. We have studied in the earlier lecture that CPU also contain memory section. Here you can see memory in which we can save the program or data given from a computer laptop. So we can increase the reliability by using PLC. Once a program has been written and tested, it can be easily downloaded to other PLC. So it is very easy to reprogram another PLC. If this PLC can damage or may be damaged due to some fault, we can use that program and that program can be downloaded to another PLC. So there is no need of rewiring the circuit. So this is the advantage of PLC, which can be used in reliable systems. Since all logic is contained in the PLC's memory, there is no chance of making a logic wiring error. We know that if we connect our laptop to this PLC, from laptop we can program this PLC, and in the laptop we can use the ladder logic program, in which we can design specific control by using logic boolean logic. So there is no chance of making a logic wiring error. So these 2 points can increase the reliability of PLC or PLC based system. So we will switch to the next slide. The program takes the place of much of the external wiring that would normally be required for control of process. Hard wiring, though still required to connect field devices, is less intensive. It is very necessary to connect the field devices, and these field devices can be placed in a remote location. From that remote location, we can connect field devices to the PLC. So it may be possible to make rewire, or we can do wiring in the field devices. PLCs also offer the reliability associated with solid state components. As we know that PLC consist of solid state devices. Solid state we means diodes, transistors, MOSFET, field effect transistor, and so on. We can also use the optocoupler in PLC, because optocoupler are also solid state devices. It means that the solid state devices can increase the reliability of PLC. So the previous 2 points shown in this slide, and the next three main points, these 3 points represents the reliability of PLC. So we will switch to the next slide. Flexibility. After reliability, flexibility is also an important feature of PLC based control panel. If we use PLC rather than use of a relay based control system, we can lose the flexibility. If we use PLC in the control system, we can increase the flexibility of the control system. Here you can see the pictorial diagram of PLC. This is the unit of output which has been connected to this PLC, and this unit is called input unit, which has been connected to the PLC. And here you can see some inputs. This input is push button. We can use push button with PLC. Here you can see the pictorial diagram of limit switch, which may be normally open or normally closed, and push button may be also normally closed or normally open. And here you can see the pictorial diagram of sensor. This sensor may be inductive sensor, or maybe capacitive sensor, or maybe magnetic sensor. It depends upon the application. So it means that we can connect different inputs to the input of PLC. And here you can see the output devices. This one is the pictorial diagram of solenoid. We can control solenoid from PLC if we connected the solenoid to the output terminals. Here you can see the output and pictorial diagram of light which can be connected to the output of PLC, and here you can see the pictorial diagram of contactor, and this contactor can be connected to the output of PLC. It means that so many output may be in the form of solenoid or light or three-phase contactor or single-phase contactor. These are the output devices which can be connected to the PLC output unit. For the flexibility, it is very necessary to create and change a program in a PLC than to wire and rewire a circuit. If we use PLC in a control system, it will be very easy to reprogram, and we cannot rewire the circuit physically, just like as we have discussed in the relay based control system. With the PLC, the relationships between the inputs and outputs are determined by the user program instead of the manner in which they are interconnected. If we back to the previous slide, here you can see the relay based control panel in which relays has been connected with each other and wiring has been done with each relay for the specific control. If we change this wiring for another circuit, it will be very difficult and will be time consuming. Here we studied that the PLC relationships between the inputs and outputs. These are the inputs, these are the inputs, and these are the outputs. The relationship of input with output are determined by the user program. Here we can use a program that may connect the input terminals or input devices to the output devices instead of the manner in which they are interconnected. By means of logic or Boolean logic, we can make a relationship between the inputs and outputs of the PLC. So the use of PLC gives the flexibility to the control system. We will switch to the next slide. So these 2 points are also related to the flexibility of the PLC. Original equipment manufacturers can provide system updates by simply sending out a new program. We know that different manufacturers develop different PLCs, and if manufacturers provide system updates, by using system updates we can change the program of PLC and the program will be updated, the system of PLC will be updated, and users can modify the program in the field, or if desired, security can be provided by hardware features such as key locks and by software passwords. In some PLCs, we can connect key locks in order to provide security to the PLC, and some PLC are using passwords. By passwords, we can secure the PLC from the unauthorized programmer or plant managers. So these features increase the flexibility of PLC and hence increasing the flexibility of the control system. So we will switch to the next slide. Lower cost. Lower cost is the third main point of modular PLCs. PLCs were originally designed to replace relay logic, and the cost saving have been so significant that relay control is becoming absolute except for power application. We know that PLCs has been used to replace relay control logic, and by using PLC we can reduce the cost of the control system, because in a relay based control system a lot of wiring and a lot of work are required to modify a new programming. The second point is about generally if an application has more than about a half dozen control relays, it will probably be less expensive to install a PLC. We know that there is small application may be possible in the industry. For small application we can use a low cost PLC in order to fulfill that requirement or logic that is required by the plant manager, and so on. We will switch to the next slide. Communication capability. Here you can see the pictorial diagram of communication module, and this module can be connected with a modular PLC. A PLC can communicate with other controllers or computer component to perform such functions such as supervisory control, data gathering, monitoring devices and process parameters, and download and upload the programs. So this is communication module which can be connected with PLC and other modules in order to make different functions such as supervisory control or data acquisition system. We can monitor different devices using this communication module, and this communication module can provide data to PLC and other module. So we will switch to the next slide. The fourth one is the main important part of modular PLC, which can increase the communication capability of the system. The fifth point is about faster response time. Here you can see the conveyor belt in which same size of glass bottle are passing from this point to this point, and here you can see the inductive or capacitive sensor which can count the number of glasses moving over the conveyor belt, and this conveyor belt may be DC based conveyor belt or AC based conveyor belt. PLCs are designed for high speed and real time application. We cannot achieve high speed and real time application by using relay logic, but if we use PLCs we can design a high speed system with real time applications. The second point is the programmable controller operates in real time, which means that an event taking place in the field will result in the execution of an operation or output. We know that PLC can be used in the real-time application, which means that if there is some event may take place in the field, maybe in the form of temperature or pressure, the result of that event may may disturb the execution or operation of the PLC. Machines that process thousands of times per second and objects that spend only a fraction of a second in front of a sensor require the PLC quick response capability. If we connect different sensor and high quality sensor with the input of PLC, so we can increase the response time of the control system based on PLC, and this will give the system response very quickly. So we will switch to the next slide. Here you can see the pictorial diagram of PLC. This is PLC. PLC means programmable logic controller, and here you can see the laptop or computer in which we have installed a software of PLC. Here you can see two lines, the left line and the right line, and there is a logic between these two lines. The left line shows the phase and the right one shows the neutral of the power. Here you can see the input. This one is also input and this one is also input, and the bracket shows the output of PLC. So we can control anything from a PLC, and it will be shown by a curly bracket, and the square bracket in opposite direction shows the input of PLC. So this PLC has been connected with the PC or laptop by means of cable. Here we can use the cable between PLC and laptop or computer. PLCs have resident diagnostics and override functions that allow users to easily trace and correct software and hardware problems. So by so so if we use PLC for the troubleshooting, so it is very easy to troubleshoot the PLC because the main program has been written in the computer or laptop. From laptop and computer we can change or edit any sensor or any input or any output connected to the PLC. So it is easy to troubleshoot the PLC. To find and fix problems, users can display the control program or a monitor and watch it in real time as it executes. If we connect PLC to the PC or laptop, here in laptop or computer we can see the real-time execution of PLC. It means that we can watch the real-time application of PLC in a computer. So we will switch to the next slide. Okay guys, thank you so much and thank you for your attention. Allah Hafiz.